Okay, awesome. So welcome everyone. So this is RSM technical core technical deep dive. This, as we said last time, this is going to be a little quite different session because we are not going to um, go over things with the app developer perspective, but more of a core developer perspective. So what we are going to do, just to give a little introduction, is go over basically the architecture of Holochain core. And we are going to focus on how a cell, so a Holochain instance works. So no networking, no conductor. We are going to start with that to simplify. Well, to simplify, and because I don't know most of the other stuff, so I guess it's a good justification also. So okay, so this is going to be we'll see how it goes because it's first time I've done this at this level. So bear a little with me, and as always, like feedback is very much appreciated to know if yeah, things are being grasped and what are the questions. I think it's better this time. It's better to ask the questions as they arise, and I unfortunately cannot pay too much attention to chat. So jump and interrupt me, jump ahead, because the concepts are pretty much dependent on each other. So if you don't understand the previous concept, it's difficult to understand the following. So yeah, I think we should dive right into it. Okay, so I cannot. No, that's okay. Okay, so just to have a little bit mental map of what we are going to do. Okay, perfect. So these are concepts that we need to understand to understand how Holochain core works, basically. So don't worry, this is not architecture or design for Holochain. Oh, Sid is trying to enter. If someone can take care of that. So yeah, basically, the green things are already done, I hope. And if not, we are going to do a quick check-in. And today I want to do the blue things. Okay, so today I want to talk about neighborhoods, authorities, entries, and metadata as far as DHT operations go. And then we are going to talk about the juicy stuff, which are the workflows and the stores. So we are going to start with the basics, basically, which is anything needed to understand a DHT operation. So first, I should stop sharing and ask. Hi, Sid. Hi, Lily. Hi, Nico. Welcome. So I want to do a check-in. Who knows what DHT operations are? And here, if you know them quite well, and who doesn't know DHT operations at all?
Do you mean Redux or RSM?
RSM.
Oh, just...
Like in reality, Redux doesn't have DHT operations. Redux has aspects. So if you know about DHT operations, it's probably RSM. Okay.
No, I mean, I know DHT operation ops from like your playground. Like that's
yeah,
right.
then I'd say you know them pretty well.
Oh, okay. Okay.
Because that part of the playground was based on RSM already.
Okay.
So first, then let me do a previous check-in because maybe it is, maybe it isn't. Who knows how a DHT works and what the basics operation of a DHT, not only Holochain but anywhere, are, and who doesn't? Here is I do, here is I don't.
I only know Holochain.
Okay, no, that's cool. That's cool. So we are going to do then 2 minutes of how a DHT works, and then we are going to move on to explaining neighborhoods and DHT operations. So, okay, I think the playground is a good tool here. So this is how a DHT works. Okay, so DHT, distributed hash table, is basically a key value store distributed among many computers. Okay, so you can see here, these are many computers. Okay, and each one of these is holding in its DHT shard. So the little piece of the DHT each one is holding a key value pairs. So for example, here I can go into and should I make that bigger? I guess should be better because I see it well, but
from my side, I think I'm monitor. It is clear enough.
Okay.
Same here.
Good.
Cool. So yeah, if we go to, for example, this node, Holochain has these two sides, right? So the source chain and DHT shard. Source chain is just unique to Holochain. DHT shards, every DHT has DHT shards. So if you can see here that DHT shard is basically key value store. So the key here is this hash here, and then the store is the entry. So why are DHTs useful in general? So DHTs in general only store content addressable content. There might be some exceptions to that, for example, Holochain, but in general, that's what they do. And why are they useful? So what DHTs do is all entries, all content is hashed, and then the content, the entry paired with its hash is stored on the node that's closest to the hash of the entry, right? So the problem we are trying to solve is how to reliably store with more or less performant read times some piece of content. So if I hash it and I store that hash with that entry besides the node which is closest to the entry, for example, here I have a node, I have the hash of the entry, and the hash corresponds to the content. So what I have is that, okay, let's take, for example, that we want to find this hash. Okay, I don't know the content of this hash, but I have the hash and I want to retrieve the content because I don't know it. So if I'm here, I can begin asking, hey, I have this hash, for example, to this guy here. I have this hash. Do you know who can have this hash inside their store? And he can go, well, I don't have it, but I know this computer that's very close to the hash you are asking me. And this computer, and then I ask this computer goes, no, but I know one computer that most certainly has it because it's the closest one I know. And then I ask again, and he tells me, yeah, I have the hash, so here it is. And we have retrieved the content of the hash in 1, 2, 3 network requests, which in here it's like meh, like there are only 10 nodes, so 3 network requests are kind of okay. But if we think of networks of, I don't know, yeah, oops, crashing the playground is not good. So if we think of networks of around 50, the amount of network requests doesn't grow linearly. So in 50 nodes, maybe I have to ask 3 network requests and I get it, or maybe 4. And in a million, with a million nodes, maybe I have to ask 6. But you see, instead of going this million node big network, one node by one, I can do very informed decisions on who to ask. Okay, so that's why DHTs are useful. It allows to store some content addressable content and then very easily retrieve it from a distributed network. Okay, so how does that ring? Here is I'm following, here is nope. Okay, awesome, perfect. Okay, so thanks for the feedback. It's great. So okay, what Holochain introduces here is that I can not only create content because, well, I can store entries, but I can attach metadata to that to those hashes. So here in the DHT chart, this hash not only contains the entry, but it also contains the metadata for that entry. In other DHTs, you cannot do that because you don't have validation. So you don't need validation because you can verify very easily if the content stored on the DHT is the correct one or not. So in Holochain, you have the ability to attach metadata, and that's why we have things like updating links, headers, all the cool stuff that Holochain does. And this is why we can do things like traversing the graph. In other DHTs, IPFS, for example, and so on, you cannot do links. You cannot get all the links from this anchor. So you can only do get me the content of this hash, which it's useful, but many applications need much more than that. With listing, I don't know, searching, like whatever your application wants to do. Okay, so yeah.
Again, just to clarify,
yeah.
So we have metadata, but the hash is still just the hashed content of the entry, right? It's not the it's still just the hashed content of the entry, not with the anything hashed into that.
Yes, like nothing. That's right. But for example, and we're going to see that with the Dht operations, when I create a link, there are two things happening in the DHT, at least. There are more, but two things. One, piece of metadata is attached to the base entry hash, right? That's the link. And then the header that created that link is also stored as a pseudo entry in the DHT. It's not an entry, but it's going to go to some of these nodes to hold it. With its hash, the hash of the header. Okay, and this is to maintain integrity, basically. So this brings to the next concept that we need, which from here it's quite let's say it's quite easy, which is the concept of a neighborhood. Okay, so what is a neighborhood is basically from the base, like a neighborhood for storing this entry. It's going to be the nodes that are closest to this hash are going to be the neighborhood in which the entry is going to be stored. And as we know, there is this redundancy factor in Holochain, not in other DHTs. So this redundancy factor basically says how big the neighborhood is. But we can also refer to what's the center, or what's how do we refer to the neighborhood? We refer to the neighborhood by the hash of where this piece of data has to be stored. So for example, in this case, we are storing the entry. So the neighborhood in which this piece of data has to go is the neighborhood of the hash of the entry. If we want to store a link, the neighborhood in which this link has to go is the neighborhood of the base entry of the link. You see how it's a little tricky. So depending on the action in Holochain, you have to store different things in in the DHT. And this is my cue to talk about Dht Ops, but this should more or less make sense. Okay, so let me clarify with this table. So this is a Holochain formal design document. It's a little rusty. It has some rough edges in the sense that it's a little bit outdated. But the parts that I'm going to show you, I've tried to update them to the latest. So here are the list of Dht operations that every action in Holochain creates. What's a Dht operation? Dht operation is something that has to change in the DHT as a result of a Holochain command. So the most clear one maybe is a store entry. Okay, so if I create an entry, what has to happen in the DHT? Well, at least I have to store the entry at the base of its hash, right? So the neighborhood that's around the hash of the entry has to store this entry, right? But you can see that there are a lot more Dht operations. And the naming here is storing, actually store some piece of data at the hash of the data, register adds metadata to something. Okay, I don't want to go over all of them, but I think we can do create entry and create link just to get a hint of how this works internally. So when we do a create entry, first what happens in our source chain? So a new header is created pointing to the latest header and pointing also to the entry we just committed. That's what happens in our source chain. What has to happen in the DHT? In the DHT, three things have to happen. First, the entry has to be stored at the hash of the entry, at the neighborhood that has to store the entry. This is the common case. Second is that the header and the element, so elements, if you remember, are combinations of header plus entry. The element has to be stored at the hash of the header, okay? Because I need to be able to do a get on the header hash. And I will be able to do that only if the element is stored at the hash of the header. If it's only stored at the hash of the entry, the nodes that are close to the hash of the header don't have that information, so they can answer you properly.
So question here, what is the hash of the header? And how is this different from header ID? Because I made a note of this when I was playing in the playground. Like there's some places where header ID appears and some places where header hash is used.
Okay.
Are they different? Yeah.
So, okay, Dht operations in the playground were based on RSM, but from 6 months ago, so they may have changed a little bit. So this is the official thing. Okay. Basically, the hash of the header is the same, like is the header ID. The only thing that can be confusing is that inside the header, there is also the header sequence ID, but that's only local to the source chain. So for example, I create the first header, the header has its hash, it's unique, but inside the header, there is this header sequence, which will be 0. The second header will contain header sequence 1 and blah, 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 blah. It's just a shortcut.
Yeah. Because basically in Playground, when you create the entry, there's, I think in some places that header sequence number probably shows up, or the hash of the header sequence number probably shows up. And so that's why I was confused.
Okay. So header ID, I don't like to use the header ID, it's header hash. And then the header sequence number is just this integer that keeps growing. Okay, yeah, go Tats.
Yeah, so just a question. So element is stored at the hash of the header. So
Yeah.
then if so that means you never hash the element together. So basically like the address of the element is the header hash. So like if you hash the element, it's not going to be the same at where it's stored at. Am I getting it right?
Yes, but the thing you have to remember is that the header already contains the hash of the entry.
Ah, I see. So is it like, okay, sorry.
No, there is no ambiguity, because like
Okay.
I cannot reference this header and I don't know what's the entry. No, the entry address is inside the header.
Okay. So essentially, you're storing every time we create an entry, you store the entry content twice, one at where the element is and one at the entry hash, entry hash.
Yes, I think so. And this is an implementation detail. I would have to go through the code to see if it's actually there, but I think so.
Okay, got it. Thank you.
Like just to reiterate for other people to be clear, the only thing I'm not sure is if in this the entry is also stored. The header is stored for sure, and I think the entry is as well because it's store element. Here, both things are stored for sure. So yeah. And the third DHT operation that has to happen when we
sorry,
do
just a quick last question on that.
Yeah.
So when we're entering the last header address, it's the hash of the last header, right?
Yeah.
Okay, cool, thanks.
Perfect. So now this last one. Oh.
Guillem, sorry, I think I have a question. I wanted to wait, but I need to ask.
Yeah.
I was thinking element was a logical topic. It means the combination of the header hash plus the entry hash. It's supposed to be element, but I see right now we have a store element. It means element is the standalone identity or entity. Yes, it means we have an entry hash, we have a header hash, and also the combination of both of them.
Actually, an element is the header plus the entry. Not the hashes.
So why we have a store element? Because if we store hash, if we store entry, both of them are going to be element. So what does it mean, store element as an operation?
It means that I need to be able to do a get on the header hash. So if I only store the entry at the hash of the entry, when I ask the DHT, I will, with the entry hash, I will get that entry because of the ping pong. Do you have this hash? No. Do you have this hash? No. Okay. If I don't store the element at the header's hash, I cannot ask for get at the header hash because the header is going to be stored at the entry hash, yes, but I don't know the entry hash. I only know the header hash. So I will begin asking and doing the ping pong and no one will know.
So another question that helps me to understand more. Header and operation are equal, one-to-one. One header, one operation is equal?
No. All these actions create one header, but this action creates 3 operations. This action creates 5 operations. This action creates 4 operations. So no.
It means one header it means one activity. Is there, can I connect header to event? It means if I make update, delete, or create, I can say they are event. For each of them, there is a one header, or maybe in one update, I would generate 3 headers.
No, one activity is one header. That's always the case.
That's it. Thank you.
Okay, perfect. Should I continue? Yes.
Please.
Okay,
please.
no. Okay, so the last DHT operation in create entry is register agent activity. What does this do? This adds the header, and I think the element actually. This adds the element besides the public key of the agent that produced it. And this is a little, it's not.
Hey, sorry, Guillem, can you just repeat that last sentence you said?
The register agent activity DHT operation stores the element besides the public key of the agent that generated. And why is that, you may ask? This is a little weird, because if we do that, we can do get me all the headers that this agent has produced.
So the question related to that one, where is the place of the header? They are the same place with entry?
No, they are stored. Each time there is a DHT operation, a copy of the header is stored in somewhere in the DHT.
Okay.
This stores the header on one place. This stores the header on another place. This stores the header on another place.
It means the header is not, there is no must, we don't need that. Header should stay beside entry or element.
Yeah, like the DHT operation always travels with a header.
Because the hash of header can be totally different than hash of entry, and that's why they can be stored in totally different places. Am I right?
Exactly. That's exactly right.
That's it. That's I wanted to know. Even for one agent, yes.
Yeah.
And this register agent activity, it is a logic to connect all the headers, to put all of them in the same. Because I have one public ID address, it means one specific neighborhood. If I connect all my operation, it means I can go exactly to my operation in one places. Am I right?
That's exactly right. That's it.
So this is like the anchor for that agent.
Yeah, more or less.
That's it. Yeah.
Activities.
Yeah. So just to reiterate, to make it clear, let's say that from this node, I create an entry. Okay. And actually, I think this is fine here in the playground. Okay, cool. Create entry will do 3 DHT operations. One will be to register the agent activity. In which neighborhood? Besides my node, like my node and neighbors of my nodes. Why? Because the place in which this register agent activity has to be stored is my agent public key. And what is the node that's closest to my agent public key? It's me and my neighbors. You see? Then second, it's going to store the entry at the entry hash. So here we have header. The entry address is going to be the neighborhood in which this store entry is going to be stored. And then we are going to do store element. Okay, don't mind this. And this is the header hash. It's going to be at the header hash. Right? And if you like, this is a big part of the of everything. If like this is basically essential for what's coming next.
So when we do a get element,
yeah,
we have to provide the header hash
or the entry hash.
Got it. Okay.
Wait, so just to follow up on Sid's question, when we do a get, when we provide the header hash, we can get both the entry and the header, because at the address of the header there's the element, right? But so when we get on the entry, it takes one more hop in DHT to fetch the header, because on the entry address there's only entry.
No, when you do a get with the header hash, you don't know what's the entry hash. So you cannot ask the neighborhood of the entry to provide you that information. Remember, you can only ask the neighborhood of the hash you got. You don't know the content of the hash. So you can only ask the neighborhood of the hash of the header.
Yeah.
And if there is no header stored there, then you're done. You cannot do anything, even if the header is stored somewhere.
Okay, so that means you only get the entry when you get from the entry address?
No, you get the entry in both ways because all the information is duplicated.
Yeah, I mean, but the header doesn't come with it.
Yeah. Get always returns an element.
Can I explain something that am I right or not? Maybe help this question. We have two kind of get header, because header is the operation connected to one entry. When we ask get header, actually we receive element. It means for this header, also this is the entry, you receive element. But there is a possibility we can ask for the hash of entry directly. It means we are asking, hey, give me the hash, it is your entry. What was the operation? We don't know. What happened? What is the history of that? We don't know. And I think the get an entry giving us just only the data, get of header giving us the element with the reality. Am I right?
One clarification. Store entry stores the entry and its header. Both.
Got it.
So when you do a get with the entry, you get the element back.
Oh, so you mean in the address of the entry, you not only store the entry, but also the header. So you're storing element on both.
Yeah.
Both the address of the header and the address of the entry. Okay. I see.
You
so
have
basically, when we do a get element with entry hash, it goes to the store where the entry is stored. If we do a get element with header hash, it goes where the header is stored, and it gives us both. Yeah.
Exactly right. Like if I don't do store entry, I cannot ask for get with the entry hash. If I do it the other way, if I don't do store element, sorry, I cannot ask for the get with the header hash. And I want to be able to do both, so I have to store both.
Thank you.
And
that clarified it.
Clarification, Dht operations always go with at least the header, always. So the header is duplicated and triplicated and maybe even 4 times in the DHT in 4 different neighborhoods.
The element inside this playground are still valid. It means the property that we see, they are still all of them valid, or we need refactor a little bit?
These properties, you mean?
Yes.
Yeah, it needs refactor because now links are not entries and headers are quite different, but the concepts are the same. Okay, so the only next thing I want to do is just to compare very quickly to the Dht operations that a create link creates. So in this case, create link doesn't create any new entry. If you remember, the link information is stored already in the header. So we only have a header. We have an element, which is the header. We don't have an entry. So what we are going to do is these two are universal. All commands store element. All commands store the agent activity, register agent activity. The only other thing I have to do with a create link is I have to add the neighborhood of the base entry, I have to add some metadata. I have to say, hey, I know that this entry is of this hash. I don't want to change that. In fact, I cannot change that. But I want you to add this piece of metadata, which is a link, besides this entry hash. Okay, so when I create a link, 3 headers, the same header, which is add link, is going to be triplicated in 3 different neighborhoods of the DHT. Okay, I think I'm done with Dht operations. So, questions?
I didn't understand.
Yeah.
The last section, I didn't understand what you wanted to explain generally. Not I didn't get what you mean. I didn't understand what are you explaining actually.
Okay, so you are doing a create link command.
Okay, you are going to explain. You are going to explain us how metadata and link are saving in DHT. Am I right?
Yes, but now we have this new vocabulary which we can use, which is what Dht operations does the create link produce.
Okay, okay. It means after create link, previously we had anchor. Right now we have a new vocabulary named link. Okay. And right now you are going to explain us that when you create a link, what's happening behind the scene with regard to operations?
With Dht operations.
With Dht operation. Okay, can you, so sorry, would you please repeat it again?
Yeah, so what's a Dht operation? You know,
No, it means, okay, we are creating a link. Link is metadata and
okay, sorry. And create link, this command creates 3 Dht operations.
Okay.
So 3 things have to change in the DHT from this single command.
Fantastic.
One of the things is that the header add link has to go besides the agent activity, besides the public key of the agent.
Okay.
One has to be that the header has to be stored, stored element in the DHT. And the third and most important is that the link has to be added as metadata in the neighborhood of the base entry.
Okay, how it's happening?
Right. So this is next section.
Okay, it means next meeting that we are going to have.
No. In 10 minutes, I want to give you an overview on how that's happening inside.
That is great. That is great. Okay. Anybody else has a question here? Because I have question maybe a little bit bigger than here.
I had a question about get element and an entry that has multiple headers. And I know we discussed this 2 weeks ago, but just mapping into today's conversation. So let's say I give the entry hash and that same entry has been generated by multiple agents.
Yeah. So in here you have, you have 2 calls. You have get and you have get details. Get is going to get you the entry and the latest header for now. Get details is going to provide you the entry and all the headers and all the metadata of that entry. But if you do get details on a header hash, you're not going to get all the headers because it's not on that DHT neighborhood that the content is stored.
That is correct.
You are asking the neighborhood of the header, and there only that header and that entry is stored, not only the other headers.
So suppose we do a get element with an entry hash.
Yeah.
And there's multiple headers. Can we say only the headers after, like, let's say in the last 1 week? Like, oh, sorry, let's say we do a get details element with a particular entry hash.
Yes.
And we ask for only activity in the last 1 week. So who has said good morning in the last 1 week? That's possible, right? Like
That's totally possible.
Cool.
Yes. Yes.
Okay.
You do get details and you filter the headers.
Got it.
Cool.
Now I get why this is so cool. Like I really, really got it. Yeah.
Okay.
Cool. Thanks.
Okay, cool. Anything else here, or should I pass to the workflows, which are very, like the workflows are the juicy stuff.
You mean about the DHT?
Dht Operations.
Dht Operation, no, but I have a topic, maybe it's good that we can discuss the relation between redundancy and neighborhood. When we are talking about the tree, would you please go to playground? We have it there. Yes. Redundancy factor, from my point of view, it means there are 3 nodes supposed to completely contain the all full change, all the history of everything. That's correct?
Wait. There are 3 nodes that have to contain the history of everything?
No. It means the whole content, it means the network. No, I was wrong. It means the whole network supposed to have a 3 full copy of all the data.
Yes, and I can refine a little bit more that now.
Okay, there are questions. If it is deep or it is not enough for this one, we can postpone later or another meeting. How we can recognize this one? Number 1, how it is connected to neighborhood. It means, is there any effect? It means it is affecting when the hash is saving. So when I'm telling a tree one, how network force the entry hash to go and sit here, because maybe we have 10 nodes, but we have I see your smile. It is a lot deep, yeah? We can.
No, it's like we are going to go there. Like that's workflows.
Okay.
Workflows is how everything is done.
Please go ahead. I can postpone my question.
Okay, so I am going to move over to workflows. So I think that, yeah, at least some of you should be familiar with this picture. This was released as part of the RSM blog post announcement article. So just like you can start seeing what the picture is about, but I think we need a little bit of explanation. So in the previous version of Holochain, everything was organized around Redux actions and Redux observers. And for those of you that have done Redux, what you do is set up an action, but you cannot listen to the result of that action. So you have to set up some kind of observer and say, when this action is done, return the result to me. And there is like a main reducer that is constantly running actions. This is a totally different paradigm. So RSM, and this is what refactored state model means, is based around workflows that interact with databases directly. Okay, so we have databases which are these roundy things, cylinder things, and we have the white round normal things which are workflows. Okay, so you are looking at the workflows that a Holochain cell or instance contains. This is it. It's a little simplified, so there are a couple of workflows missing, but apart from that, there is not much more than this. So in a sense, it's pretty simple. And I think in 10 minutes, we can do an introduction and see what the general gist and flow is, and then next week we can dive deeper onto the workflows if we want. So, okay, this new workflow architecture is really, really cool. Why? Because it guarantees correctness. This is the part of guarantee correctness that you see in RSM blog posts and so on. And why is that? Because every action that a workflow does, so every action that a Holochain instance does, is always persisted into the database so that when you shut down the conductor at any point in time, there is persisted state of what was happening at that moment in the Holochain instance. And when you boot up again, the workflows can resume exactly at the state they were. So this is what we mean by correctness. Okay, so any general questions around that? Otherwise, I'm going to dive a little bit into workflows.
Sorry, the whole workflow, I think, is a big topic. We are going to cover next week, and right now you're just going to give us overview, or you're going to cover the whole workflow right now?
No, I'm going to do an overview now.
Okay, thank you.
All good?
Fantastic from my side.
Awesome. So all of these boxes are workflows that do something. Okay, just to give you an idea, Genesis workflow, okay, it's a workflow on what does it do. So it basically creates the first 4 entries that any Holochain DNA creates upon install. Okay, so how it works is that each one of these workflows is normally executed from the conductor. Like you can imagine here, the conductor calling the Genesis. The conductor receives a call, which is install application, and that creates a cell. So setups all these databases and then says, okay, init Genesis workflow for this DNA. And this Genesis workflow, what it does, it commits this, I think it's 4 because it's the capability grant here as well. So we have this Genesis workflow committing these 3. And if this workflow hasn't been run, like nothing can work, right? So this commits to the source chain and to CAS. I'm going to explain what are those in just a bit. So that the cell is initiated and in good state. Okay, and if the conductor is shut down before that, then the Genesis workflow is run again. Okay, and everything is transactional. So that's an idea of how a workflow works. So let's do the most important workflow there is, which is call some function. Okay, and I'm going to do an overview of what it does, what it touches, and then what else it triggers. So a workflow generally is called with some parameters, stores things on the databases, and triggers other workflows. And these green arrows are workflows triggering one another. Okay, so callzone triggers produce Dht ops, that triggers publish to Dht, and things like that. Okay, so let's do callzone function. Okay, so the conductor receives a call from the UI which says, hey, commit this, no, not even commit, like create entry or whatever. So this workflow, what it does is gets the WASM, which is your application code, loads it, executes it, and all its contents after the call has run are stored in the source chain database. Okay, the source chain database together with CAS are probably the most important ones. So CAS is a content addressable store. It's basically key value of this hash is for this entry. right? And this basically won't change ever because the hash of an entry cannot change. So what it does is, okay, commit this entry. You're going to commit this entry. Okay, let's mark, let's add this new header hash into your source chain list of headers. Let's store the header and the entry in the cache database, and let's trigger the produce Dht Ops workflow. Okay, so again, this creates an entry. The entry commits a new header hash here, new header and entry here, and triggers the produce Dht operation transforms. And then it goes to sleep. So the UI returns, and from the UI's point of view, this is already committed. But there is still things happening on the background. So if you remember, we settled this, what actions create with Dht operations. That's what this workflow does. It gets the new things that have been committed onto your source chain and creates all the necessary Dht operation transforms. Okay, so what has to change in the Dht from me having created this action? Okay, what it does is stores them into the author Dht Ops database, which stores everything that we have committed to the Dht, and then it triggers the publish to Dht, which is a fast push, and this is what Hedayat was asking. This is the workflow that gets each of the Dht operations and basically goes around the network asking the nodes to hold the Dht operations. Okay, so this is an overview of the most important flow that there is, and that's it pretty much. Like, there are a lot of conditions happening here, but if you want to see the code, like, you can really go to the code inside Holochain creates Holochain source core, and then workflow. I can send you the link if you want. And if you can see, these are all the workflows that Holochain does, and they correspond to each of these boxes. And each of these is pretty simple to understand, actually. It takes a while, but it's not anything, it's not rocket science. So you get the current head in case of concurrent creates. You, let me see, you invoke the zone function. You validate that things are valid. What are you doing here? Yeah, you run any callbacks necessary, like create link validation callback, like these hooks that we now have, you run them, and then you're done. So if you want, like, this code is actually readable if you more or less understand this and want to spend some time looking at this.
That's great. Just again, if it is not proper for this session, let me know. Can you go back to the code? I was wondering how it is preserving the status of a workflow and resume or rehydrate the workflow.
Right. So actually, this is one of the workflows that doesn't get rehydrated, because if you call the conductor, but the conductor dies at that moment, the call, like, the UI receives an error and it doesn't get rehydrated next run, you know?
What about internal one? It means
exactly.
I'm in the middle of internal one and something is down.
Yeah,
how
exactly.
we rehydrate?
Yeah, integrate Dht operations, for
example.
example.
Okay, yes.
Yeah, so basically this is it, which is, let's go to the integration limbo database and read what is there that has not been completed. So here, let's go to any of these databases that we care about in each of the workflows, and let's read what's left to do.
It means at the beginning of operation, we are writing all the step, and when it is finished, we just tick, 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 and when it is finished, when we hydrate, we double check to everything is finished. Yeah.
Exactly.
So is there any what's the name? If rerun again the one operation, the idempotent, it means operation mostly should be idempotent. Yeah, it means if one time for any reason I double, it's enough. I can talk about it later. Continue.
Yeah.
So can I ask what Redux was like? We basically didn't have the checklist at the start, right? So we just ran through it, and if it dropped off, then it just dropped off.
Yes. And actually what you have was kind of like a queue of operations. Like when you wanted to do a get on the network, get entry, that got committed into the queue of actions that were still queued to happen. And whenever other actions were finished and whenever there were resources, that action was resumed. So it's a totally different paradigm here, because here you can actually, like there is no central queue for tasks, and you can dispatch based on priority. Like you're going to give much more priority to calls on function, which is the user doing something, than to gossiping. Right? So gossiping is not going to block calls on function. But in the past, in the Redux version, it was going to be much slower.
So where is this priority defined? Like is
good question. I don't know the answer to that. I don't know where it would be defined, but I think it's on the conductor level. Yeah, that's a good question. I don't know, but you can imagine what is blocking the user has max priority. What is things that it's background and we can live with it for now, it's less priority. So some things like calls on function is priority, publish to DHT is second priority, maybe after calls on function. And then servicing gets is quite a bit of bigger priority as well, because there is some node asking for it. Like this is when I receive a call of, hey, this other node wants to know about this hash. Do you have it? And that's blocking that node as well.
So a related question, let's say, we did a create entry and, halfway through the DHT ops, the conductor dropped off.
In this workflow?
And the conductor, sorry?
In this workflow?
Yeah, in this workflow. And let's say the conductor drops off and doesn't come back online again.
Yeah.
Does the record of what's been completed exists on the conductor, right?
Yeah, because
so
you have
So technically the DHT won't know that the job is only half done. Like
that's
someone will have one shard, and so that still exists.
Yes, but like in this case, no one knows, and the only one who knows it's you, and you just died.
Yeah.
So it's like when you come online, you're going to be producing the DHT ops and pushing it. Until then, for the DHT, is as if you were offline.
Correct.
Because you basically were.
Yeah. I get it. Yeah. Okay. No, I asked that more to make sure I understood it right. That makes sense.
Cool. Well, I don't want to cover more terrain today, so and I would just want to acknowledge it's 5 minutes over time. I'm okay to do another 10 minutes of questions around this, but if somebody wants to drop off, that's totally cool. So yeah, questions, clarifications, like this is really key to get if you're going to be looking at the code or actually doing some fixes, pull requests, and so on. Anything in this, like this is a new paradigm, but RSM has pushed forward.
So I have a question, Guillem.
Yeah, go ahead, Thomas.
I apologize, my internet connection is not great. Just going back to the playground, was what you showed us the latest structure for the RSM, the header and entry? Have you emulated the latest RSM spec?
No, not yet. And this actually is one of the things that we want to do. Like it seems that I'm able to ask help to some collaborators. So props to that, and Anastasia and Jakub, and maybe I'm missing someone, but sorry if that's the case. So this is one of the reasons we are doing this, because we want to migrate the playground to RSM.
Okay, cool. So I was thinking it'd be really helpful to have like a network packet diagram. So you see something like TCP/IP where you can see each of the contents of like the structure of the header and the structure of the payload. So like, sure, it'd be great to have that image.
Well, that's basically what we have here. It's just that the structures have to change a little bit. Right? Or are you talking about something else?
Yeah, that's basically it. That's the structure of the header and the payload, right?
Yeah.
And I think perhaps it's, I'm not sure if it's that what you mean, Thomas, but what was coming through my mind is there was this book which was mapping the journey of a cash note or banknote through like its lifetime from person to person, and it was kind of telling the story from the perspective of the banknote. So perhaps it could be interesting to play with like, okay, I'm now the entry, and where am I like going? What are the transforms? And what's like the story of the pieces of data? That could be perhaps also an interesting point.
Yeah, that story is that the one of the things that is on the core concepts?
I'm sorry.
So is that story on the core concepts of Holochain, or is that another thing?
It was more like a thought of what could help kind of getting the picture in the mind, like plastic, just trying to like imagine, okay, now I'm the entry, and like replay the story from my point of view. Like I'm the entry, and now I'm traveling by the pipeline to validation, and I'm getting stamped, and now there's, yeah, like getting the space actually from my point of view. But it's just like, I think it's just like the education tool or something like that. Yeah.
Right. Yeah, that's interesting. The only tricky thing is that at one point you have to basically triplicate yourself if you're the entry. So hey, where am I going now? Okay, mitosis.
Yeah, and perhaps one question. So can you please put the map of the simplified RSM on the screen? Yeah, thanks. So I'm looking like there's the call zone, then there's the source chain transactions, and the entries and headers are put into the CAS. And this is before the validation still, right? Or validation is the next step afterwards? Or is validation already happening somewhere in here?
Mm-hmm. So yeah, could you mute? I guess I get some feedback.
Yeah, sorry.
Okay, thanks. So this is one of the gotchas. So if we like from the point of view of a good agent, if I'm trying to commit an entry that's not valid, the sum function should fail, right? But if we don't do it here, if, for example, we wait for DHT validation, basically we are returning from to the UI without having run the validation, so no idea if what we are trying to do is valid or not. So one of the steps here, and I can basically show it, I think, is to run the validation. So like you can see here, we are validating system validation, and then we are validating app validation.
Technically, also you'd want that also for private entries, right?
That's a good question, but I don't think so. I don't think validation makes sense in private entries.
Why not?
Because here you're only doing this out of courtesy, so that DHT nodes don't get invalid stuff. Like where validation is actually run and actually does things is on the receiving nodes.
So you're saying it's just a courtesy, and so if it was a private entry, it doesn't matter, even if I put garbage entries.
Like it's the same as checking before committing, really.
Yeah.
Because like,
but then if I were to, yeah, but then it could be like maybe I'm writing a blog and I want to give access to it to my subscribers. I would want to check that it's valid or whatever.
But like
yeah,
you cannot, the receiving nodes do not receive anything, so they
yeah.
don't even can start validation. Validation of what?
Yeah.
Yeah, but this is like the first pass, kind of getting rid of the. Is that the same step as I think you were explaining?
Getting rid of?
Like getting rid of the garbage in a sense.
Yeah.
So if there's like obvious invalid data, they just get filtered out and they don't get sent. But that means that this is in a sense, if I was hacking my agent, then I actually send those things to the DHT, right? Because I could bypass this kind of courtesy step or filtering step.
Exactly.
Okay.
Because otherwise we wouldn't need all this work here, right? So here we can't assume anything about what we are receiving. If everyone is a good actor, then okay, we don't even need to validate anything because everyone is a good actor. So we are only doing this in case something we receive is invalid, and the only way that something we received is invalid is if someone has hacked this workflow and commented the validation, which, as you can see, like I could comment this block here and I'm done. That's how you create a bad agent in Holochain. So yeah, and actually the hash will be the same, the hash of the apps, because the apps themselves do not change. It's just that I'm not invoking the validation callbacks. So this is one of the side effects of RSM. Like hacking Holochain, it's much easier now because you can understand the code much better.
Thanks.
Cool. Any more thoughts?
Will we cover some of the other DHT ops in next few weeks, or not really?
You mean covering all
update,
of
delete.
every? Okay, what I can do is I'm going to share these links, and please do not write, but just comment. So I'm going to send you these links, and you can review them. And please don't write, just comment, and you can comment your questions for next week.
Okay.
I don't think it's necessary to go, like, it's a little tedious to go over all of them.
Yeah.
But if you have, like, if you are reviewing anything and you say, yeah, I don't know what this does, you can just comment on here.
Cool. Yeah, and I think also playing with Playground is explanatory. Like it's quite evident if we just play with it enough.
Yeah, like the Playground, the only conceptual change in Dht operations is, as far as I know, that a date entry now updates the header as well as the entry, so it has to update Dht ops. The same for delete. And links do not store entries, because links were entries in the past version. Links are not entries on RSM, so they don't need to store things. So actually, it's like in the previous version, creating a link and updating an entry were the same cost. Right now, creating a link is much more lightweight than updating an entry.
Yeah.
And if you want
and
to
so
play around
therefore
with this,
that confusion with Redux of, if you update back to the original entry, that doesn't occur because we're also updating the header. And so
yes,
yeah, got it.
Yeah. If you want to play around with this also tells you global stats. Like, for example, here I only have 60 Dht operations, but they are triplicated because redundancy factor is 3. So globally, I have 180 Dht operations held collectively by the nodes. So I have 19 ops per each node. And if you want to play around with this, like this stay constant, but now there is more stuff to be held, right? More duplication. Okay, any other questions? I think we should do same thing next week to dive a little bit more for those that are really interested. And then maybe the following one will return to, like, if we still have energy for this, which I think we'll do. We can return to the app development perspective with people already had some experience with RSM. Okay, cool. So I think we are good to finish. Yeah, go.